All right, so a quick example of the delta, and it's complicated. It's going to take practice. You're going to have to read the answers. I lowered the max attempts to 4. It's just staying on task. It says the function f of x is a log, so the inverse of a log is an exponential. Since it's base 2, it's going to be 2 to the x. All right, and it says it is log 2 negative x minus 5 minus 3. It gives the graph. And the first thing it wants you to do is to replot the points. So if you're going to replot the points, right, x and y will switch. So this point here was -9, -1, right? It's going to become -1, -9. We're going to move the points in a second. But the first thing I'm going to do for f of x is up here is record some things I can see. It's a log, base 2, okay? I'm going to jot that down. I'm going to jot down that I can see the domain is -infinity to a vertical asymptote of, and I got bad vision, it's -5. And I can see the range is all values. It goes forever both ways, so the range is all reals. And I'm going to write it like infinities because that's the way delta works. I can see that there is a vertical asymptote of x equals -5. When we switch x and y, that's going to help us a lot, okay? And that's going to keep us here. And then we're going to have to solve this equation for x, right? And if there was a negative here, you'd have to multiply by negative at some point, but there isn't. So I'll add the 3. Y plus 3 equals log 2 negative x minus 5. Put that in parentheses, and now I can write an exponential. 2 to the y plus 3, right? So 2 to the y plus 3 is going to equal the inside, which is -x minus 5. I hate the negative, so I'll multiply everything by a negative. And I'll get x equals -2 to the y plus 3, and I'm going to move that 5 to the other side. This is going to be our inverse that we'll need at the bottom after we move the points. All right, that's how you do the inverse solving for x. It's tough. B to the L equals n, L equals log B to the n. So now I'm going to, hopefully this all stay. It does. I'm going to go PC operation. I'm going to start moving points. So -9, right, on this decreasing function, -9, -1 is -1, -9, boom. -7, -2, so -2, -7. That must be -2, -7, yep. -6, -3, so -3, -6. All right, 3 points, 3 points. We draw the graph. It'll only let you draw the graph if it's correct. So it drew the graph, and boom, it gives me all this stuff. And I'm going to scroll down. Hopefully that stuff stayed. That's perfect. All right, so now I'm going to go input these things off screen. All right, so I will put in the inverse we created, right? It is, and there's logs down here, but I just have -2 raised to the x plus 3 minus 5, and it has, okay, and now it has this one is different. This one had a vertical, so we are going to have a horizontal, right? Because x and y switch. Instead of being a vertical at x equals -5, it's at y equals -5. The range and domain switch. So the domain of this function was -infinity to -5. That means that's going to be the range of the inverse. -infinity to -5. And I look at the dotted curve, guys. It is decreasing. That's where a lot of our mistakes on. And its domain, well, the range was all real, so our domain has to be all reals. It tells you what you wrote, and there's the green arrow. All right, I'm gonna make another video of exponential going to a log, so you have that as reference.